Daniele. First of all, thank you so much for giving me this opportunity to present my work. Good evening, everyone. My name is Surayyn Selvan, and it is an honor to be able to present to you the developments of my thesis research, the Dynamic Urban Nodes Emotion Simulator, here at CUSP. So before we begin, I would like to briefly introduce myself. I was born and raised in Kuala Lumpur, Malaysia, and my entire academic and work background was in architecture. And in 2018, everything I thought I knew about architecture completely flipped, turned around inside out when I started my master's degree at IAC. And that was when I birthed my thesis project. So the Dynamic Urban Nodes Emotion Simulator, or DOONES, is my thesis project, and it was developed over 9 months at the Masters in Advanced Architecture second year program in the Institute for Advanced Architecture of Catalonia, under the tutelage and guidance of Areti Marcopoulou, along with Nicole Kirova, Eduardo Camoro Martin, and fellow IAC faculty members as well. So DOONES aims to be a design support tool for the evaluation and simulation of dynamic urban environments based on emotional analytics. So now this is everyone's favorite statistic provided by the United Nations, who projected that by 2050, there would be an increase of 68% of the global population in urban areas. But what does that mean in the context of my project? Well, with the rise of the urban population, there are studies that have been conducted that shows an increase and a correlation between mental health disabilities and the urban environments. And this is especially higher in urban settings. And the World Health Organization predicted that by this year, there would have been an increase of up to 15% of mental health disorders in the global burden of diseases. So what does that mean? This means that we need to design livable cities that would benefit the mental well-being of our citizens. Now, many cities in various countries have already realized the importance of well-rounded health and have started to implement strategies such as pedestrianization, for example, to create better urban environments. So, for example, with these case studies, they focus on different scales of implementation, from a neighborhood scale in Barcelona all the way up to the master planning scale in Chengdu, China. And the overall objective is to improve health of their citizens and encourage more active lifestyles. But the most vital component of designing livable cities are the citizens. It is important to engage with the very people who are inhabiting the space that is being designed. Now, these case studies look at the importance of the role of the community in facilitating urban design initiatives, such as in Plaza Glorias in Barcelona, or on the flip side in Madrid, where the citizens felt like they did not benefit from council planning of the city center. Or in some cases, like with Space Hive in the UK, the communities have taken the reign in generating funds as well as implementing civic projects together with the city council. Now, not only do we need to engage the citizens, but we need to understand the quality of the urban environment that we intend to intervene. These case studies focus on a variety of data collection and visualization techniques to map various urban parameters, such as livable streets, like in Arturo, or the happiest, prettiest, quietest streets, like in Happy Maps. Whereas in the data walking project, the researcher uses non-conventional methods of urban visualization to map the environment through walking. But the most important aspect of this project is that it uses low-cost data gathering technology, which makes it super accessible to everyone. In parallel, we also need to understand how people perceive space in order to design it as inclusive as possible. These case studies focus on various data collection techniques in order to visualize user perception of their environments, such as in chatty maps or mapping emotions, which use digital mediums such as surveys or extracting social data. Or in the San Francisco heat map, the researcher used physiological sensors in order to get biological data from the users. So how can we aid decision makers in designing or redesigning cities with better environments for mental well-being? By engaging the citizens in order to derive urban qualities of space in parallel with their perceptions, without limiting it to solely visualization techniques, ensuring an integrated system of processes, and also offers opportunities for stimulation. Well, we can answer this, we can tackle this aspect by looking at volunteered geographic information because of the dynamic flows of information with regards to the cityscape as well as individual perception. There are also existing databases and repositories that take advantage, that we could take advantage of, and are easily accessible by all the stakeholders involved in the urban design process. And such an example of VGI lies in social media platforms through user-generated content. Now, within the context of Dunes, the focus is on the potential of review-based social media platforms, such as Google Reviews and TripAdvisor. Now, the methodology that I generated could be applied to other platforms as well, but I focused on these two platforms as a start. Now, this form of social media offers user experience-based data complemented with ratings from a graded scale, and all this information is geolocalized. And in addition to all this is that there's also auto detection for spam, which is a huge help in text analysis. Now, speaking of text analysis, Dunes explores the natural language processing techniques of sentiment analysis and topic modeling. This is to derive quantitative values from the polarities of the texts, as well as the most frequent words to aid in design decisions later on. However, these platforms and this form of analysis has its limitations, especially in terms of accessing data through API requests. And with Google Reviews, for example, the non-English reviews are automatically translated into English, so the original sentiments of the text could potentially be lost. Overall, with most natural language processing techniques, the analyses are more accurate with English text data. Now, to test the credibility of these review-based social media platforms, I conducted a validation experiment using Google Reviews, looking at the context of mobility in Barcelona. Focusing specifically on metro stations in Barcelona, I extracted 2,500 reviews from 24 core stations, and more than half of those reviews were actually text data, which proved sufficient for my analysis and research project. Now, when I conducted the sentiment analysis of this text data, the biggest conclusion that I extracted was that there was a visible discrepancy between the average Google rating and the overall text sentiments. And this meant that the text data offered a higher resolution of analysis for design. Now, we could also derive geographic inferences from the sentiment analysis, such as when the subjectivity of the texts were analyzed, it was seen that the more objective comments and more objective reviews were made towards the residential areas in Barcelona. And when I conducted the topic modeling, I found that the most used keywords could be grouped into four major categories, which were accessibility, service, comfort, and security, which correlated with the council survey data that were rated the lowest. So this study proved that review-based social media platforms through natural language processing techniques can be used to conduct sufficient levels of analysis. This allowed me to move forward with Dunes and form the hypothesis for my research, which was, if emotional analytics is correlated with urban indicators, sentiments in dynamic urban environments are able to be digitally evaluated and simulated. Now, in order to test this hypothesis, I divided the research into four main phases, which consisted of data input, data synthesis, data evaluation, and simulation. Moving forward, I decided to zoom into a more urban scale setting for a higher resolution of analysis, and that's why I chose Ciutadella Park in Barcelona as a case study. Now, the Dunes analysis was conducted on a grid of 50 by 50 with 20 meter spacing because it was the most efficient resolution for me to perform, given the technological limitations that I had. Now, we begin with the data input, where we identify geolocalized points of review on the review platform or platforms that are the most relevant. Then through data mining, we have a text database with the parameters of our choice. And based on the resolution of study, we could either aggregate or isolate this data. So with Google Reviews, I managed to extract 34 points of location with various typologies. And with TripAdvisor, I extracted 13 points. So moving forward with the thesis research, I decided to aggregate this text data because of the similarities of these platforms, as well as some overlapped geolocalized information, forming a total of 36 points of review in Ciutadella Park. Now, the mining provided me with a database of over 9,000 texts and reviews to analyze, not including user information because of privacy. And most of these geolocalized points of review, as you can see, were rated on the positive end of the scale. And through this initial phase, we can derive certain geographical information, especially in terms of activity hotspots, which are the center of the park, the main fountain, which is a tourist hotspot, as well as the Barcelona Zoo. Now, once we have the database ready, we can conduct preliminary natural language processing studies to form higher resolution heat maps, as well as form inferences on the most frequent words used. Now, through the sentiment analysis, we can see that the average sentiments of the text lean towards the more positively neutral zones. And when compared with the average ratings, there is a huge discrepancy, as you can see by this calculation. And I also mapped the most frequent words used in the text that had the positive sentiments, as well as negative sentiments, in order to be used later on to inform design decisions. Now, the core of DOONES lies in the data evaluation phase. Here, we identify the emotion that we intend to analyze. We extract the quantified data relevant to the emotions using urban indicators. And to facilitate this process, DOONES proposes an interactive survey that feeds a classification and regression algorithm in order to generate a metadata heat map. Now, although there are a plethora of emotions to study and analyze, DOONES focuses on three main ones relevant to urban settings: safety, comfort, and health. And through the previously mentioned case studies, we can see that we can quantify urban elements using existing repositories or data collection technologies. User perception can be quantified through surveying methods and social data, but most importantly, causal relationships can be determined between urban elements and user perception. So in order to quantify these emotions, research was conducted on what urban indicators could potentially influence the user perception of the urban environments with regards to safety, comfort, and health. And after studying all these papers, these elements I found could be grouped into four main categories of urban indicators, which are accessibility, visibility, circulation, and infrastructure. And in order to develop the methodology, DOONES focuses on 9 core urban indicators. Now, the question is, how do we determine the interdependencies of these urban indicators that affect the sentiments of these emotions? This is where the DOONES interactive survey comes into play. By embedding visual information with urban indicator values, through user responses, we can evaluate numerical data that result in the gradients of these emotions. The interactive survey has 2 specific question typologies, which extract sentiment values as well as keywords to evaluate these emotions based on urban indicators. Now, with the visual preference question, there is a definite values of sentiments embedded into the images, which form the basis of the analysis. And with the scale grading, the sentiment values are more dynamic because it is highly dependent on the majority of the responses. Now, because the case study focuses on an urban park setting, diverse images of various urban park conditions and environments were extracted to be used in the survey. And using various quantification methods, the urban indicator values can be embedded into the image. So, for example, with this visual preference prompt for positive health sentiments, the embedded information includes varying degrees of urban indicator values. And to ensure a smooth launch of the survey, I used Google Forms as a platform to conduct it. And throughout the duration of the survey, I managed to get 256 responses from 20 different countries. Now, although the user profiles can be expanded upon, I focused solely on the age group and gender identity for the development of this methodology. As a result, for the survey, we can see that the sentiments for safety were highly influenced by urban indicators related to visibility, infrastructure, along with the frequency of movement. And with the sentiments regarding to comfort, urban furniture, light levels, and vegetation, as well as proximity to roads, transit, and exit points were very influential on the sentiments of comfort. In terms of health sentiments, Urban infrastructures, distance to the nearest exit, as well as frequency of movement were very influential on the sentiments. Now, this is especially interesting given the current context of the pandemic right now that includes frequency of movement. And with the overall sentiments, we can see that infrastructure, accessibility, and circulation greatly influence the gradation of the user perception. And through all these values that I extracted from this survey, it is fed into a regression analysis model in order to classify the sentiments of the relationship of urban indicator values. And all this, the results of this regression model is used later on in the data simulation phase. Now, we also extracted keywords descriptions from the visual preference questions, and using the text data from the responses, we can develop our very own emotion classification model in order to analyze existing reviews based on the three emotions. Now, with the model I set up, there was an accuracy of 0.69 because of the size of the data set that I acquired. Of course, the bigger the data set, the higher the accuracy. Now, how do we extract the emotion sentiment values from the reviews? Well, from the classification model, we can extract weightage of these emotions. And when using simple mathematical calculations with the average polarity of the text, we can derive numerical emotion sentiment data based on the three emotions. And now we can apply this model onto the existing reviews to generate average values of these three emotion sentiments. And when generating the emotion heat map for Chutodaya Park, it can be seen that the emotion that has the highest weightage is comfort, followed by safety and health. Now, when we overlap this information, we can highlight potential risk areas or areas of interest. Now, to further our analysis and conduct our emotion simulation, we could focus on isolated emotions or aggregate them. Now, moving forward with this methodology, I decided to focus on a specific area in Chutodaya where all the emotions overlap with each other. Now, we need to extract the urban indicators determined earlier for the case study. Now, using various computational strategies, existing databases, satellite imagery, and sensor data, I was able to extract numerical information on the urban indicators specifically for Chutodaya Park. Now, with all the urban indicator values extracted, we can move on to predicting and simulating emotion environments of our area of interest using the machine learning models that we set up earlier. The extraction of the urban indicator values are also applied to the area of interest using the center as well as the area as normalization for the data. Now, with regards to determining the sentiment value of the area of interest, calculations using the weightage and distance of the three nearest points of reviews determine the sentiment of the area of interest. This is the kind of interpolation method that I used. Now, moving forward, we could look at three forms of data to inform our design decisions, which are topic modeling from the earlier analysis. We could look at image-based data, or we could look at the highest weighted emotion. Now, the setup for the digital environment for the simulation is pretty straightforward, as you can see in this video. So first, we activate the urban indicator layers, which we intend to manipulate. In this case, walking paths, vegetation area, benches, and trash cans. Then we draw the analysis boundary in order to launch the code. Then once the code is launched, we can retrieve the values and manipulate the urban indicators in order to achieve the desired value that we are looking for. So in this case, the comfort value was a bit lower than the rest of the emotions. So I looked at comfort and tried to manipulate the urban indicators in order to see how to increase the positive percentage of the comfort sentiment value. Now, in comparison with the original comfort heat map, there are changes that can be seen once the urban indicators were manipulated, with a minute but visible increase of sentiments. And although this increment is very small, it shows the potential in quantifying emotions through urban indicators. Also, the manipulation of one emotion also affects the others. So decision makers can use this information in order to balance qualitative decisions on their projects or focus on one specific emotion that they want to achieve. So in conclusion, DOONES proposes a tool to aid in the design of livable cities for mental well-being. by engaging citizens in measuring the quality of the urban environment using quantified emotions in order to make better informed design decisions. So what does DOONES have in terms of the potential of its methodology? Well, this methodology of correlating urban elements with emotions in order to simulate design could be applied to various urban contexts, such as tourist locations. All that needs to be done is adapting the emotions as well as the urban indicators, as well as the survey prompts in order to suit the analysis. Potentially, I could see it also being applied in a more macro scale of a building by using auto-generated geolocalized points within the building boundary, and by adding urban indicators such as materiality or a qualitative data such as aesthetics. And to wrap up, here's a video that shows DOONES in a nutshell. With the rise of the urban population, it can be Okay. With the rise of the urban population, it can be hard to ignore how we feel in cities. And nowadays, telling people how you feel has become so much easier through social media. Imagine if we could take all this social data and use it to design for the collective urban experience without compromising you. The Dynamic Urban Nodes Emotion Simulator explores this idea through 4 processes, starting with data input, where we identify a location of interest and extract geolocalized points of review from various social platforms. Then, we clean the text by removing punctuation, numbers, non-English words, and nonsense words, so the texts are nice and shiny. Then, we move on to data synthesis. Here, we use the natural language processing technique of sentiment analysis to calculate the polarity of these texts between a range from -1 to 1. Then, using the average values, a heat map is generated over the case study to visualize where people feel positive or negative. For further analysis, topic modeling is conducted that tells us what words are frequently used in these points of review. Now, which emotion do we analyze? Well, DOONES focuses on 3 main emotions: safety, comfort, and health. But how do we evaluate them? In data evaluation, DOONES proposes to measure these emotions using various urban indicators, such as the distance to the nearest exit or surface area of vegetation, to name a few. Basically, using a machine learning algorithm, urban indicators related to accessibility, visibility, circulation, and infrastructure are correlated with the average polarities. This creates a navigatable heat map that shows us the percentage of safety, comfort, and health. Depending on the values, we could either zoom in or zoom out to continue our analysis. In parallel, DOONES proposes an interactive survey, which is a public web survey specifically curated to build upon this research. Through your participation, the interactive survey helps us to understand how you feel about urban elements with relation to safety, comfort, and health. Lastly, everything comes together in data simulation. After computing the results of the interactive survey, the potential emotion landscape of the case study can be predicted by adding or removing these urban indicators. Decision makers can then manipulate these to achieve a percentage of safety, comfort, and health relevant to their specific projects. Whether you would like to evaluate existing spaces or new proposals, DOONES offers a new perspective on how we can potentially create more inclusive public spaces. So now tell me, how do you feel?
All right, excellent. Thanks so much. Super clear presentation. Thanks.